Okay, welcome to AMM 120, and today we're going to talk about ratio, rate, probability, overview, and really talk about birth rates and death rates in the US. Okay, so this is just a quick review so you can look at it in more depth. I gave you some examples, but for some of you who don't like math necessarily or don't remember, we're just going to do a quick review on ratios and rates because that's what we look at. A ratio, just so you know, as a review, is a value obtained by dividing one quantity into another. So that's how you get a ratio. Okay, so it indicates a relative magnitude of a numerator and a denominator. So we will be looking at a lot of ratios in this class, obviously. And just to give you an example, and we look at different categories for ratios. So for example, a sex ratio at birth. It's the number of male births per 100 female births. That would be the sex ratio. And child to woman ratio. That's the number of children aged 0 to 4 years divided by the number of women aged 15 to 44 years. So, you're looking at, basically proportions. Do pay attention that we specify parameters such as age. So, for example, for the child-woman ratio, we look at children aged 0 to 4 years. That means up to 4 years, not 5 years and up. It's once they hit 4 years, that's it. No one older than 4. Women, we look at primary childbearing years, which would be 15 to 44. So that's why the age parameter is set in that fashion. Rate is a measure of frequency. Okay, so that's basically a frequency in which an event occurs in a defined parameter, defined population during a specific time period. So rates are basically a special case of a ratio, and rates tend to be associated with population change. So the rates can go up, they can go down. And we look at numerators and denominators. So the numerator is the count of events that occurred during that specific time frame, and the denominator is the midpoint of the population, or depending on what we're looking at, but person to years or person to time units of people exposed in the same time period, exposed to the same event. Now, the people that are exposed to the event are included in the denominator. Now, the only thing with the rate, we look at sometimes different types of rates because there could be people in the denominator that aren't exposed to the event, and that could give you maybe a more distorted or skewed number. So there's crude and refined rates. Okay, so crude rate is the initial number that you get divided by an X number of the total population. So for example, crude birth rate would be the number of births divided by a total number, X number of the population times 1,000. Okay, and you get a birth rate. You do the same with the death rate. Now, the crude rate, again, is the number of events that's divided by the total of the population. Now, the problem is the denominator contains individuals that may not be susceptible, that couldn't be part of that event. So it's affected by age structure. It can make comparisons difficult. So a good example is the divorce rate. If you just say the crude divorce rate is the number of divorces per 1,000 people in the population. Okay, but what if in those 1,000 people that you get, you have minors, or if you had people that are single, that have never been married? Well, what do you need to be before you can get divorced? You need to be married. So they're part of that denominator, and yet there's no way they could contribute to the divorce, the number of divorces, so why are they in the denominator? So when you have a crude rate, it can include people that just wouldn't be susceptible to that situation. So that's why we have a refined rate. Sometimes it's called the specific rate, where it's the number of events that are divided by some homogeneous subgroup of the total population. So it could be age specific, like an age specific death rate. Deaths in a specific age group divided by the midpoint population of that age group, okay, because they're part of that age group, so they belong. And that can give you a more clear, better understanding and clearer picture. We also look at probability. We look at likelihood. We're projecting. We're trying to anticipate. These are all words and terms that we use. We're trying to see where, even though we're at 2015 right now, we're trying to see what numbers are going to look like in the year 2020, 2025, 2050. So the likelihood that some event will or will not occur in some group of exposed people during a course of a specific time frame. So probability is the number of events divided by the number of outcomes, basically. So an example, probability of dying between birth and age 5. That's the probability that a child will die between literally birth and exactly age 5. Not age 5 and 10 months, not age 5 and, 325 days, literally from 0 to the first day they turn 5. Okay, so it's very specific parameters there. Probability of surviving from age 20 to 25, probability that a person of exact age 20 will survive to exact age 25. Now, the birth rate is what we're looking at because it's linked to fertility, is the ratio of total live births to the total population in a specified area. So it's specific. So we look a lot, we're going to focus on the US, but we're going to look at global comparisons over a specific time frame or a period of time. Often expressed as the number of live births per 1,000 people of the population. Another word is natality. It's another term for it, but most of the time we call it birth rate. And looking at the fertility rate, currently it's at 1.88 births per woman. This is the final 2012 numbers, the 2013 numbers, and obviously 2014, they're still working on it. I told you they take a while. So right now we're looking at about 1.88. China's looking at about 1.66 and Japan 1.41. So ours is a little bit higher, but most of them are trending down. And we'll discuss in class how Italy, I'm posting some articles actually. Italy and Germany just announced an issue. Italy actually had the prime minister had a huge press conference saying that her country's dying, and that people aren't having children. It's a problem. So you can get a comparison from the 1920s to 2010, which is our last census. Births per 1,000 women aged 15 to 44. As you can see, it went down, obviously from the Great Depression, then it goes up. Then we had a economic collapse in the 70s, and it didn't quite recuperate from that, and it goes up a little bit, and then it goes down. We actually experts were expecting a mini baby boom around going into 2007, 2008, 2008. Obviously, we had the Great Recession, and that killed that. So they were expecting a mini boom, and there was a slight increase going into 2010, but very slight. It's basically continuously going down overall. It is going up in certain areas, but mostly it has been going down. And we're looking at all ethnic backgrounds. They're consistently going down. So whether it's white, black, Native American, Asian, Hispanic, it's going down. And a world historical kind of overview, so you can see from the 1950s to a projection, we are projecting that it is going to continuously go down. And so you can get a comparison from early 1900s to the last 2012, which is 63 in the U.S., 63 births per 1,000 people in the population. So as you can see, from 127 in 1909, it has continuously gone down. Okay. Now, is it all in the economics, or is it? Definitely, we've seen the greatest drops in the Great Depression, the 70s energy crisis, the Great Recession. That's where we've seen a larger drop. But is there more to it than that? And that's what I want to discuss in class. But it does keep going down. It keeps going down by small percentages, 1% a decrease from 2012, but it's still going down. Lowest rate on record since the government started tracking fertility rate in 1909 was in 2007. That's when the Great Recession hit. But overall, we're still, even with the economy going back, and even if it bounced fully back, is that number still going to keep going down, which is our projections is that it is. So I want you to think about it, and I want us to discuss why. Why is it going down? Why the decline? I'm posting 2 articles on Blackboard in our Week 2 folder. And what are the potential consequences? So one talks about, yes, it's the economy, and that's what most experts say. It's expensive to have kids, and it's getting too expensive. The cost of living is higher. But is there more to it than that? So I want you to think about that and bring those thoughts to class. And are there potential consequences? And there's quite a few that can come up that people are debating or challenging. I do recommend a very interesting read, which is What to Expect When No One's Expecting, which is a riff on the What to Expect When Expecting books. I'll bring that one to class, but so you can see it's a very interesting demographic book, and it's written a little bit better than some other books, not quite as boring. But it talks about potential consequences to continuous decline in birth rate. Most people think, oh, it's great because we are overpopulated. We have too many people. I mean, look at our freeways, right? Sometimes I always joke and I say we need another plague because there's just too many people out there. So this seems like a good thing. But let's talk about if it's all good, the potential good consequences, and maybe potentially, if there are any, bad consequences. Now, one thing to definitely mention, we're looking at when it comes to fertility rate, we're looking at live birth, okay? That means the baby has to be showing some signs of life or it can't get counted. So it has to be completely extracted from the woman's body, the mother's body. It needs to show some sign of life, breathing, heartbeat, etc. If that is witnessed, then it is considered a live born. Okay, once that is witnessed, it is considered a live birth and it gets counted in the fertility rate. However, if there shows no signs of life, then it cannot be counted as a live birth. Okay, so now all live born infants should be registered and counted. Okay, irrespective of gestational age, so it doesn't matter if they're premature or not, or past the typical 40-week gestational period. They're looking at if it's a live birth, it gets counted regardless of when they're born. Now, all should be counted regardless if they're alive or dead. It's just if they're alive, they get counted as a live birth, and if they're dead, then they get counted in the birth death rate. Okay, for the infant death rate. If they die anytime following the birth, after being a live birth, then they have to be registered and counted. Even if it's minutes or hours after, they get counted as a live birth and then get counted as a death. So a live birth registration, what goes on there? Basically, the data that needs to be on there is the date of the occurrence, the date of registration, the place of occurrence, the type of birth, normal or C-section, and who was attending the birth. Okay, who gave birth, the nurses that were there, doctors, etc. And that's my little one. I think that's my third one. The last one, I can't remember. I have 4. I can't keep track. Data on the infant, we need to know the sex. We need to know legitimacy status and the weight at birth. They don't actually put the length. Some people think they don't actually put that, but they do put the weight. Data on the mother is the age or the date of birth, age of the mother, once it's they deliver, the number of previous children born alive. All the registration forms have that. Ask that, date of marriage or duration of marriage if they are married, and place of usual residence. So that's the information that's on the live registration form. Okay, so this concludes part 1 of our fertility and mortality section. In part 2, we'll talk about death rates and mortality rate. Thanks.